Hello everyone. Today we will discuss about the homogeneous function. If a function is given, how to check whether that is homogeneous or not. So the definition of homogeneous function is, suppose if f of xy is a function of two variables of degree n, then if we substitute in place of x as xt and y as yt, or x as tx, y as ty, and if we can able to get t raised to n f of xy, then that function is called as homogeneous function with degree n. So here the power of t gives the degree of that corresponding function. Or one more method is there, where if for any given function we can able to express it as x to the power n phi of y by x, or y to the power n phi of x by y, then also we can say the function is homogeneous function with degree n. So this is the definition of homogeneous function. Now this definition or this criteria we will apply to this function. Here it is, f of xy is equal to x cube plus x square y plus 2xy square minus y cube. So we will apply all the three methods. So if I substitute x as xt or tx, y as yt, so this f of xy becomes x cube t cube plus x as xt. So x square is x square t square, y is y into t. So here we are substituting x as xt. So x square becomes x square t square, y is yt plus 2, again x is xt, then y square is capital Y square t square minus y cube is capital Y cube t cube. So if we observe here, in all the terms, the power of t, here it is t cube, and here t square into t is t cube, t into t square is also t cube, and last term is also having t cube. So we can take t cube as a common term. So if we take t cube as a common term, it is left with x cube plus x square, this term and this term, x square y plus 2, this one 2x y square minus y cube. Okay. So f of xy, that we have substituted x as xt, y as yt, and we have obtained in the form of t raised to n f of capital X capital Y. So in the form of again the same function. So if we can see the definition here, so the function after substituting x as xt, y as yt, if we can able to get some power of t and f of x comma y, then this f of xy is homogeneous function. It is homogeneous function of degree n is equal to, here n is equal to 3, of degree 3. So we can check in this way. The same example, here we can use the another method, which is, so if I take x cube common from each and every term, so first term will be 1 plus second term, if I am taking x cube common, so x square is there here, we have to divide it by x. So when I multiply x cube inside, y by x into x cube, again I will get x square plus, here also if I take x cube common, but we have only x, so we need to divide it by x square. So 2y by x whole square minus, so we are taking x cube common, means we have to multiply divide by x cube, y by x cube. Okay, so whenever we multiply this x cube inside, again we will get this same term. Each and every term is in the form of, let us say, phi of y by x. So as per this definition, if we can, after taking x to the power n common, if we can able to write the function as phi of y by x, that function is called as homogeneous function of degree n. So here n is equal to 3 again. Similar way, instead of x cube, if I take y term as a common term. So highest degree term of y is y cube. I will take y cube as a common term. Here y cube is not there. So we have to multiply divide by y cube. So one of the term, numerator term is y cube. So it become x by y whole cube plus, now we are taking y cube term common. So we are dividing it by y square. So combinedly we can write it as x square by y square or x by y whole square plus, here again y square term is there but we are taking y cube term common. So it would be x by y. So when I multiply this y cube inside, what I will get? Y cube into 2 times x by y. Y will get cancelled, it becomes 2xy square. So we are getting again same term here. Minus, so here y cube is there and we are taking that as a common term. So this entire term is again function of x by y. Here also 1 we can write it as y by x raised to 0. So 1 is also we can express as y by x. Here also this 1 we can write it as x by y to the power 0. So each and every term of this expression is in the form of x by y. So it is in the form of y raised to n some phi of x by y. So if we can able to express a function in this form, then that function is called as homogeneous function of degree n. So here also again n is equal to 3. Okay. One more example we'll see. So here the function is f of xy is equal to x plus y upon root x plus root y. So out of these three methods, we'll take first method, x is equal to xt, y is equal to yt. So the given function becomes f of x comma y, which is f of xt comma yt is equal to, now wherever x is there we are substituting xt in place of y capital YT under root xt plus under root yt. From the numerator we can take t term common. So in the remaining will be x plus y. Then from the denominator we can take root t as a common term. So when we are taking root t as a common term, now it is left with root x here and here it is root y. That is root x plus root y. Okay. So now this root t we can write it as t raised to 1 by 2, and if we shift this t raised to 1 by 2 the numerator, it becomes t raised to minus 1 by 2. So already one t is there in the numerator, that I will write it as t raised to 1, and this denominator t we are going to shift to the numerator. So it becomes t raised to minus 1 by 2, and remaining term is x plus y upon root x plus root y. Okay. So now here the base is same, t raised to 1 minus 1 by 2 is t raised to 2 minus 1 by 2, which is 1 by 2, and rest of the term is nothing but it is f of capital X comma capital Y, because we have given f of x this way, same term we are getting here in place of small letters. Now we are having the function in capital letters. Okay. So again, by recalling the definition, f of xt comma yt, if it can be written in the form of t raised to n f of capital X y, then this n is the degree. So here n is equal to 1 by 2 is the degree, and the given function f of xy is homogeneous. Similarly, one more example we'll see here to clear the method of homogeneous function, or how to check whether the function is homogeneous or not. So here u is equal to sine inverse of x plus y upon root x plus root y. Again I will substitute x as xt, y as yt. So u becomes sine inverse of xt plus yt upon under root xt plus under root yt, which gives sine inverse of t as a common term in the numerator, which is t into x plus y. Then root t is the common term in the denominator. It is left with root x plus root y. So this gives sine inverse of t to the power 1, and this root t, when we shift to the numerator, it becomes minus 1 by 2. So combining the t term, which gives us t raised to 1 minus 1 by 2, then x plus y upon root x plus root y. So here, so as per the definition, if we can able to write t raised to n into f of xy, then that function is called as homogeneous. But here what we are getting is sine inverse of t raised to 1 by 2. Remaining expression is as it is, x plus y upon root x plus root y. So because of this t term, we cannot write this as again u. Okay, so we cannot able to write it as t raised to n into u or t raised to n into our f of x comma y, and this we cannot take outside of the sine inverse. So therefore this u, given u, is not homogeneous. So here u is not homogeneous function, but it is a function of homogeneous expression, because this expression which we have given, x plus y upon root x plus root y, which is earlier in small letters, now same expression here we are getting in capital letters. So this expression is homogeneous, but this u, which is sine inverse of the expression, is not homogeneous. So u is not homogeneous, but it is a function of homogeneous expression. Okay, so this we can rewrite as it is given, sine inverse of t raised to 1 by 2 x plus y upon root x plus root y. So from the given we have obtained this. This we can write as sin u is equal to, so sine inverse term we have shifted this side, sin u is equal to t to the power 1 by 2 x plus y upon root x plus root y. So this expression is homogeneous with degree 1 by 2. So if I am taking this as f of u, so f of u is homogeneous function with degree n is equal to 1 by 2. So the given function u is not homogeneous, but when we are taking it as sin u, which we are denoting it as f of u, this f of u is homogeneous. So in this way we will check whether the function is homogeneous or not. So there are two cases now we have seen. One in the earlier example, first and second example, the function, in both the cases the function is homogeneous, but in third example the function is not homogeneous, but it is a function of homogeneous expression. So I hope everyone understood with this how to check whether the function is homogeneous or not. Thank you.